So it's pretty exciting to be here actually today relative to what I'll talk about in a fairly short section is give you a perspective of from a silicon server vendor what it really means to go end to end from silicon out to solution to end user. So a lot of times for Linaro we'll talk about individual components or standards, but we don't necessarily pop up a level and think about how all of that comes together finally to the end user. And I think especially today when we talk about ARM on ARM, Jacob touched on the fact that there's a perspective of ARM on ARM as a developer using an ARM environment, but there's also the end user running everything on an ARM platform. And I'm going to probably tend a little bit more to that. So I work at Marvell. Previously to that, Cavium, if I go far enough back, Calzada is a startup in the ARM server space. And my focus is really on partner and ecosystem enabling. So one of the questions, especially early on, we'd really get is, well, why ARM? And in some cases even, what is ARM? I think that's really evolved over time. And so now with where we've gotten to in the server market, especially the last 3 or 4 years with a level of diversity, with AMD really coming back, with accelerators picking up momentum, ARM really being seen as not only a viable but really compelling alternative in the server space for a number of reasons, some of which are listed here. And I think from a Linaro perspective, we certainly understand and appreciate the aspects of an open architecture. And that's true both as we think about silicon design, and I'll touch on that, but then also the software perspective, industry standards, and that's both how do we leverage existing standards like UEFI forum and what comes out of there, but then also as ARM has complemented that with things like SBSA and SBBR. The ecosystem that continues to evolve and build on, and I'll touch on what we mean by TCO, both so total cost of ownership, but also acquisition. And all of these are important as we are out talking to members of our supply chain as a silicon vendor, but also our end users. But that fundamental continual growth of ARM across many segments does help and play into what we do in the server space. So just briefly, Marvell, give you background. So Cavium was acquired and fully integrated into Marvell as of July of last year. Marvell is a silicon company focused on infrastructure, very focused on the fundamental areas of data center and extended infrastructure, and I'll touch a little bit on what those products are. Just some of the metrics on the company side here. Certainly it is an engineering focused company. From the 5,000 employee base, highly focused from the engineering team side, worldwide in terms of multiple sites in the US, as well as Israel, India, China, and recognized as an innovator in the industry. So I talked about infrastructure. This is really where you see the blend of Cavium and Marvell. From the Cavium standpoint, the focus there was very much on the compute side, both server and networking. Certainly historically, Cavium really started in the security space around the network or the security product line. And then with an acquisition of QLogic with both fiber channel and Ethernet, and then kind of classic, what we would call classic Marvell of storage and networking. So as you think about how we really focus on core areas and how we can leverage our engineering across those pieces, it's a pretty natural integration of how Cavium has come into Marvell and where Marvell is really seen as leading silicon vendor now across this space. So that's it for the company background. So I'm going to use ThunderX2 as the foundation for my examples. I want to treat it more as kind of an instructive rather than a marketing selling pitch, because what I really want you to appreciate is when we think of all the components that have to come together and how they come together to deliver that solution, what it means, different stages and different ways we engage with the community. So our focus as a company is silicon. That's really what we monetize and that's what we deliver. So around the silicon piece, We partner closely with ARM, obviously. We are an architectural licensee. So we will license the ISA, but then we will do microarchitecture extensions and optimizations for the areas that we're going to focus on. Now, a couple of presentations this week, I think in particular, you probably heard a little bit from Andrew from Sandia yesterday, where software can either adjust to the hardware, or hardware can be designed with the software in mind. We've really tried to lean that latter part. And so what I mean by that is, as you look at the architecture of ThunderX2, we're embracing ARM v8, 8.1 from the feature standpoint, but we've taken it further in terms of fully out of order support up to 4 threads per core. Memory subsystem is a fundamental area that we've focused on. And that's critical to a lot of the applications and the customers that we've targeted. And I'll talk about how that comes together. But in our case, 8 memory channels per SoC as really a unique extension around the ARM architecture. Full cache coherence, so we support dual socket, and integration from some of the I/O subsystems. So all those components where we target how we design the silicon, and as we're doing that, close partnership with the open source community in terms of enablement, but also end users in terms of what their applications, how they're structured, how they're going to take advantage of this technology. So even though our focus is very much on the silicon, we have to have an enabling platform for our early partners, and that's true both software and hardware. So we spend a lot of focus around our reference platform, our CRB as we'll call it. And to be able to deliver this requires significant collateral around our silicon, as well as layout of the physical board itself. So we'll help drive schematics and things like that. But we don't deliver that. We partner with an ODM. In our case, it's Gigabyte for ThunderX2. Many of those systems have gone into Linaro as well as other partners. So many of the folks in this room have had direct access and usage to that. Now, that's very much a standards-based platform. So it's actually server-ready certified. We worked with ARM on some of the aspects of that standardization and of the testing, and I think it's a significant milestone from the ecosystem as ARM rolled that out last year, and that is just giving more confidence to the ODMs as well as the OS vendors who take advantage of it. As part of that CRB, we will focus on a reference firmware implementation. So as we think about how we engage with the data center group on different aspects of firmware design and development, we've got our own captive team to help drive that within Marvell, but then we also partner with AMI as a commercial firmware and BMC partner to support our broader ecosystem, because we're not going to be able to scale to necessarily support the range of hardware and system vendors we work with. And AMI's been in this business for probably about 25 years. So as we work with an OEM, they're used to working with AMI. So it eases that engagement, built on those standards, and as little change from kind of their model that they're used to as possible. Now, in parallel, as we're doing all this, we're also working on the kernel upstream, right? So a lot of times, things that we're driving directly or in partnership with ARM or with Linaro, we're pushing those enablement bits up even before silicon has come back in sample form. So there's an interesting timing challenge. You know, we had the presentation from ARM yesterday on some of the future technologies. There's this interesting back and forth between disclosing the technology before you're ready to ship, but you necessarily need to do that to have the kernel enablement, and then we've got to worry about the timelines with the OS distros. These are things that, frankly, as an ARM community, we've had to learn over the years. I think we've now gotten pretty good at it, and we understand the distros and vice versa. But all of this is happening in parallel well before the general market is even seeing the product. Now, from the CRB standpoint, then, we'll also drive a lot of analysis, testing, optimization, both at the chip level and the system level, as well as from a software perspective. So that's going to help us as we go engage our end users and can accelerate our shipments once we're ready for production volume. So all of this is happening really 9 to 12 months prior to your production release. And the things we'll do with Linaro is getting CRBs into Linaro well before production release as well. So sometimes there's question of, well, why can't we just put this in the open? Well, that's a challenge we have as a silicon vendor in terms of we want to leverage the testing and evaluation, but at the same time, it's not quite ready for prime time. All this has to be done and able to supply, to ensure our supply chain is ready and enabled. Now, part of what we also have to keep in mind is as an ARM server vendor, we're going to be installed into primarily an existing x86 world. I'm not aware of anyone that's building their entire data center purely from ARM yet. I'll be happy when that day comes. So we have to really make it very easy for that conversion. So tools, management, deployment, all of those things have to look, feel, and fundamentally operate very similar, or if not exactly, to what x86 world is used to. So when we've got open source management tools like Slurm that you'll see in an HPC world, or other examples, debuggers, profilers, all those things are critical to be as common as possible. And on the physical side, as we work with an OEM, similarly, we need to be able to fit into existing chassis, use existing power supplies, all those components as well. So these are the aspects that we will juggle. We obviously want to show our differentiation and value in certain areas, but it can't be just changing out things just because it's nice, because it's going to affect the cost and the time to solution for the members of our different supply chain. So what I want to do is use some use cases with customers to kind of amplify what I've just described. And these are all public, so we're at a good point of being able to talk about them. And they really span a couple of different areas. Certainly, HPC and big data is one, I think, really shining example that we've got. Some of the ARM native type applications as well as cloud or hyperscale. So let me start in the HPC space with Sandia. This is really a major milestone for the whole ARM community in that in November at the supercomputing conference in Dallas, Sandia announced with their Astra system that it's one of the now top 500 official supercomputers in the world. First time for ARM. Sandia is part of the Department of Energy National Laboratory System within the United States. Basically, Sandia manages a stockpile of nuclear arsenal for the United States. So this is not only challenging workloads, demanding compute, but very fundamental and highly mission critical for the entire US. This is a system that the OEM here is HP. It is the Apollo 70 platform, so that's an infrastructure that HPE has had on x86 and now is carried to ARM. So they've leveraged that reference platform that I talked about, but they've got their own design within that Apollo 70 platform. So all the work that we did early on enables HPE to fairly easily convert and integrate within that environment. Red Hat is the OS. RHEL is fully supported as part of that HPE deployment. HPE's strategy in terms of go-to-market is to really use a lot of third-party software packages. So that includes open source compilers as well as ARM Alinea tools, RogueWave tools. They use OpenHPC for a lot of the platform management and infrastructure. Sandia is interesting in that they really made a significant investment in ARM early on. They've been running test beds on ARM platform back to my Calzada days. So this was very, very early in the, even very early, late 32-bit, early 64-bit type of platforms. And that's what it's taken to get to this level where you really need an end user to make that kind of commitment and work with you on development, optimization, and those kinds of things. So this is, I think, a really something to spotlight that everybody has had a level of contribution to because of what it's taken to pull all these components together. Los Alamos is another lab that is part of Department of Energy in the United States. This has been a large, highly scalable physics simulation set of workloads. Now, Cray is the OEM in this case. So with Sandia, it was HP. With Los Alamos, it's Cray. Cray has a different go-to-market than HP. Cray has a very integrated software stack. So they pretty much own the OS. They have their own compiler, performance libraries, tools. So they're much more self-sufficient in terms of owning the software stack. And this is the first time Cray has taken a very optimized compiler and performance libraries over to the ARM architecture. So now because we've got really two different OEM models, but we're able to support that with that common enablement base that I talked about. The other thing I'll mention, and you've seen some analysis over the last 6-9 months in the market of different compiler performance on ThunderX2 and on ARM architecture in HPC, comparing open source GCC with the ARM Alinea compilers, as well as the Cray compilers. And the good news is they're all doing pretty well, and no one compiler wins across all codes. Depending upon the code, you'll see advantages of one compiler over the other. The good news for, I think, the industry as a whole is you've got choice, right? You really have 3 choices of being able to leverage that. The Riken presentation yesterday talked about Fujitsu's compiler as part of that. So more and more of that choice and optimization continues to come along. A third example, again in the HPC space, but now with a third OEM, is Atos Bull and CEA, which is French atomic administration. Again, heavy workload, heavy mission critical focus. Across all 3 of these HPC examples, all these codes are very memory bandwidth intensive. And so taking advantage of pure performance advantage of what we deliver, not just as an alternative architecture. And Andrew talked a little bit in his presentation yesterday from a Sandia perspective in terms of the number of codes that they see benefiting right out of the chute beyond just some of the micro benchmarks. Same thing we've seen with CEA. So this is the Sequana Bull platform. It's pretty innovative architecture. 3 nodes per blade, a very dense, compact design, and this is also Red Hat based. So moving from the HPC kind of classic OEM model, we also have Microsoft. So some of you have seen Leonard Van Doren here in the past presenting on Microsoft's work at Azure. And this is for Azure infrastructure. And Leonard's described that a significant portion of the infrastructure at Azure can easily be supported and optimized around ARM. ThunderX2 has been a key component of that. Microsoft's been talking about this now going on 2 years since Open Compute Forum in 2017, where this engagement was originally described. Now, this is a different model from the hardware standpoint in that Microsoft's been very open within OCP about the platform design, Project Olympus. So there's collateral and design information that comes out of Open Compute, because that's the fundamental goal there is, let's say, open source for hardware. And Microsoft's model is more a captive design supply chain rather than a classic OEM model. So again, we're going back and leveraging that common CRB across different customer engagements and different enablement model. And you see different customers taking different paths for their use cases and workloads, but that common enabling piece that's critical for us. Another really interesting partnership that we've had, and it really fits the Linaro space, is what we've done with the University of Michigan, one of the major research institutions in the US. Michigan has a 2-rack cluster of ThunderX nodes focused in their data science and big data environments. So you see some of the metrics here in terms of the size of the configuration. Michigan is using this both in their classroom teaching around big data and data science, but also for their research community. And this has delivered some significant performance advantage for them running on ThunderX. But from the Linaro perspective, University of Michigan's been working directly with the big data team that's part of the data center group here, consuming the big data and Hadoop builds, some of the additional optimizations that have been done, additional features and functions that have been added in. And I think this is a great working model for us going forward in that we don't have a commercial ISV or a commercial owner of big data software in the ARM market today. So we have to have a very functional, optimized, open source solution. Apache by themselves wouldn't necessarily do that. So Linaro stepped in, solved that gap, now can work directly with an end user like Michigan and really optimize both the development done here and how Michigan consumes that. They've helped on some of the roadmap definition. There's additional things like Ambari that we're looking at and talking about. But I think that's a model that the more we can enable and help facilitate, the more efficient we'll be within Linaro for other types of workloads. Last one I'll talk about purely from the workload I think is most exciting as we think kind of what I'll call the classic ARM on ARM, right? So as a server guy, when I think ARM on ARM, it's the workloads that I can run on an ARM infrastructure in an ARM environment. So with Cadence is one of the major ISVs in the EDA, the electronic design automation space. So as a silicon vendor, you use EDA tools for your silicon design and testing and validation. It's a critical component of how you build your silicon. So with Cadence, we publicly announced at TechCon in October full support for their suite of tools on ThunderX2 in the HPE Apollo 70 platform. There's a white paper out, there's performance numbers, there's information about the application. But what's key here is now we've got commercial ISVs who really are kind of at the top of the software stack, leveraging all the work that's been done over the last many years of firmware and kernel and tools to have now commercial software where we can really build and monetize all the initial investment that's happened. And we see performance advantages because of the density of cores and the bandwidth that we've got on ThunderX2 for Cadence. You'll see that in the white paper. But we've also got an interesting captive market with many silicon vendors here as part of Linaro, but in the market who are ARM focused and who will be motivated to be able to use ARM infrastructure rather than purely x86. So we're able to take advantage of this within Marvell. Part of what we talked about at TechCon was work that ARM's doing, as well as HPE using this internally also. The other thing I'll call your attention to here is the red box, Flexera licensing. So the reason that's there is when you're a commercial ISV, a commercial software vendor, in order to monetize your software, you need a licensing wrapper and licensing tools around your software. So Flexera is one of the leading vendors here. We help sponsor some of the work to ensure that all those tools are supported on ARM. That was publicly announced last year. And so this now eases the path for other commercial ISVs that want to take advantage and develop and deliver on ARM. So that gives you a sense of some of the use cases, how we go from early silicon all the way out to delivery. Some of the benchmarks, some of the metrics that matter in terms of in order for us to get the end user's attention and where we are going to spend a lot of time on our optimization, both in terms of how we design the silicon, but how we optimize the software and where we push on things like libraries. Just a couple of figures of merit here. Application throughput, this is where density of cores and density of threads really pays off for us. Application latency as it relates to memory bandwidth, going back to the memory channels that I talked about. And these are, these are decisions that each vendor is going to make as they do their design. But the great thing in this ARM ecosystem and in ARM world is you've got those options. As well as PCIe, number of I/O lanes with different accelerators and different options that people are looking for in the server space. This becomes more and more important as we go from PCIe Gen 3 to 4 to 5 and others, and overall performance per dollar. And I will say for a lot of these numbers, I'm kind of giving you the flyover, but there have been a lot of public third-party numbers published over the last 6 months. Places like Serve the Home as an independent industry analyst, some of our end users. Simon McIntosh Smith from University of Bristol has been pretty active in publishing a number of papers as well, where some of these places are looking at both absolute performance, but performance per dollar and what the deltas are. This just gives you some example in terms of power and cost. And a lot of these specific examples are more at the silicon level because we don't necessarily control the system side. So different system vendors are going to focus on different targets for where they're going to optimize. And in some cases, they may leverage a lot of that existing infrastructure and not be able to take advantage of some of the savings here. And I think you'll see that in future generations where this continues to improve. Back to how the silicon thinks about the software, there's different optimizations that you're going to look at in a cloud workload and a cloud analysis, things like VM density. And the core count where I'm looking more at scale within a socket or across a system, not necessarily always single thread performance that are key in this market. And then you contrast that a little bit on the HPC side, where here it's going to be absolute compute performance and where I've got a lot of the memory bandwidth that's going to help me in that. Another interesting workload that you are seeing a number of the ARM server vendors talk about is Android in the cloud, which is I think, a really interesting example of, again, that ARM on ARM concept. So this is a case where maybe I want to do CI in the cloud. Maybe I want gaming in the cloud, where I'm moving from an Android device to how do I do that hosted on a server. A lot of that today is on an x86, and I pay a really big performance penalty because of the emulation and conversion from ARM to x86, whereas natively, I'm going to have a lot of benefit. You heard Huawei at the keynote yesterday talk a little bit about Hatch and gaming. I think that's a great example of where there is an opportunity in the server market for us to really drive and take advantage of this, not in spite of us being based on ARM, but because we're based on ARM. And I think Jacob leaned a little bit that way in some of the discussion this morning at the Packet keynote, where how do we really think about optimizing and leveraging the advantages of ARM, not purely just playing as a catch-up. And I think we're going to see more and more of that. Okay, so in closing, a couple of things that I'd like to challenge or have the audience here as a whole think about. And what's the role of Linaro, and how do we really work together to continue this momentum now that we've got a great foundation? And I think first and foremost is continue the leadership in the upstream. It is so critical when we're out talking to our end users and can show the capability, the quality, where ARM and Linaro sit in this community, is especially around kernel, compiler, tools. That's really key for a lot of our customers. So we just absolutely have to continue that. I touched on the big data University of Michigan engagement. That's a model I hope we can continue to see come through in other examples, where we can have a really fundamental, important leading end user, customer, and workload, where it plays to the advantages of ARM as an infrastructure play, but also play to the advantages of the Linaro expertise and engineering. The more we can do this, the more impact, and I think the more relevance Linaro will continue to have. I'll call this walk the talk. We've talked a lot about how do we get ARM systems in the hands of you as developers, but I don't want to stop there. I want the infrastructure to be completely ARM. I want the build systems to be ARM. I want the test systems to be ARM. I want everything to be ARM-based. And that's really, certainly from a Linaro perspective, I think critical for how we look at the infrastructure. Certainly that's what we are driving from a Marvell standpoint, and that's really what we want to be able to see and I think become much more efficient as an organization. And finally, how do we work with end users? The HPC SIG that's part of Data Center Group is pretty interesting right now because I think this is exactly what we've been able to establish. We've got members like Riken, like Sandia, where the expertise, the domain understanding of the workloads and the space that we're trying to address, it gives us so much more confidence because we've got the experts in the room. And those experts can go back to their infrastructure and validate and test and even take it to a further step. So the more and more we're going to target specific segments and areas, the more that we can pull some of those partners, customers in, I think is really critical. So with that, I thank you for the time, and I think I'll turn it over to Elsie again.